Hello everyone, welcome to our session. Today is March 6th, and I will go over some new R commands for homework number 7. First off, I will be starting my R code with just setting the working directory with this command. Oh, you should be familiar with this command by now. Run it, and then I'm gonna go to my working directory. Go to the working directory. And then I'm going to read in this file with the command read.csv, and I'm going to view some of the lines in the project data frame. So we can see that there are student names, and then we have the project score. Okay, and I'm going to save the average and standard deviation into the name as average and STD. So this will be our mean for our data, and this will be standard deviation for our data. Okay. The first, I guess, the new command you'll be learning is called the QQ norm. It maybe this is too small. I'm going to zoom in. Okay, I think it's better. So first, new command is QQ norm. This is just the name of the data frame, and then I am going to. So we saw previously that the project score has all the scores, and I'm going to draw a QQ plot for the scores. Okay, it looks not good. So I'm going to go ahead and read another file, which is a cps.csv. This file you use for your project. I'm going to sort that as a wage data. And again, using QQ norm command, I'm going to draw a QQ plot of the wages. Okay. And I can add a line called with the QQ line with the same data in between the parentheses. Okay. All right. So what does QQ plot do? It compares the theoretic quantiles and then sample quantiles. So for example, if we want to compare a data set for a normal distribution, we use QQ plot. So this is a theoretical quantile, and this line is a sample quantile, which means that if the sample quantile data or sample data matches the theoretic normal distribution data, the data should line up on this line. So we see that this is not a good normal distribution. Okay, because on data here is deviates from the theoretical normal distribution, and data here also deviates from the theoretical distribution. Okay, so this we can say that by looking at the QQ plot, the distribution is not really normal. Right? These are some things that, well, you don't need to know all these. This is just the getting rid of the one outlier here. I mean, I'm gonna go ahead and just remove these all outliers and then draw this one more time, and then draw the line one more time. Still, even though we remove the outliers, the distribution is still not normal. Okay. So QQ plot give you an idea of how your distribution is whether normal or not. Okay. And the other command is to learn is called p-norm. Okay. If we go back to our data, we found that the average is 11.236 and then standard deviation is 1.19. Okay. And this gives you the probability of getting a number less than this number. So what it means is probability of your sum variable or project score less than equal to 11.236. With this command, you can find out the CDF, the cumulative distribution of certain number. Right? So we have the mean of 11.236. So if we input this, or if we run this line, we're probably gonna get close to 50%, which means 50% of data is below the 11.236. Okay. What if we want to find out the probability of project score being less than 12.5? We can just do like this, 12.5 with the average of the average of our population mean and population standard deviation, and then run it. This is in percentage. So we see that project score, about 85% of the project score was below 12.5. Okay. What if we want to find out the complement of that? Find out the project score at least 12.5. Well, we can just find the complement by subtracting this probability from 1. Okay, which means the probability of getting at least score of 12 point, greater than 12.5 is about 14%. Okay. We can also do something like this. The probability of getting a score between 10 and 12. First, find the probability of getting a score less than 12 and subtract that from probability of getting a score less than 10. By doing this, we get the probability of getting a score between 10 and 12, which is about 59%. So this was the second, I guess, this new command that you'll be needing for homework 7. Also, there is one thing I want to highlight is the approximation of binomial distribution with normal distribution. So this is, let's say we have a fair coin. If the coin is fair, we'll get a tail or heads with 50%. And if you flip the coin 100 times, it's likely that we get 50 heads and 50 tails if we have a fair coin. So I'm gonna run. This is the probability of getting a head or tails. And n is the number of the runs. And this is the average. By average, we'll get 50 tails or heads. And this is the standard deviation. This is just a formula for the standard deviation of binomial distribution. Okay. So what does this command mean? So we found the average of our population distribution. We know by flipping a coin 100 times, we know that we're gonna get heads about 50 times. And then this is the standard deviation of the binomial distribution. Remember that binomial distribution, there's only success or non-failure. So there's only heads. There's only two outcomes. So getting a head or tails, or whether it's going to be success or failure, something like that. So this line means what is the probability of getting heads less than 60 when we have population average of 50 and the standard deviation of 5. Okay. So we know that the flipping a coin has a binomial distribution, but then here we are using the p or normal distribution to approximate the probability. Okay. All right. Which makes sense because probability we're getting head is 50%. You run the coin 50%, 100 times, then about 50% of the time we're gonna get heads. So this is what the probability of getting less than 60 heads. So most of the time it's gonna be correct. This kind of verifies our prediction that about 98% time it is probable. Okay. The last one is the Q norm. It's a quantile command. I said the number representing X percentile. Okay. So the Q norm takes 3 inputs. First one, this is the X, the percentile. I mean the quantile, and this is just the average and then the standard deviation of a distribution. Okay. So this give you the what's the number, what's the point, how do I say? What's the point that has the point at which the 25% of the data is below, and so which is equal to the first quartile, and this is the point. What's the point which has the 75% of the data below, which is also equal to the third quartile. So if I run this one, we had the average of 50, and then standard deviation of the 5. So this one, the output is about 46.6. How do we interpret this? About 25% of the data will be below the number 46. Here the average was 50. And then the first quartile is 46. If you remember the IQR, which is the difference between third and the first quartile, we can use this command to figure out the IQR. So this is the third quartile, and then this is the first quartile. And if we subtract these two, we will get IQR. All right. I hope it was instructive. Thank you for listening.